Every day, the subway pulls into the 96th Street subway station countless times, comes to a full rest, and then accelerates from a standstill, pulling out of the station. But how is the train able to start moving from a standstill? First, let's go over some key concepts involved in this question: friction, force, and the law of inertia from Newton's first law. Friction is the force that resists motion in a direction. In the case of the train, there is static friction between the train and the track in the negative x direction, making it more difficult to start moving from a standstill. The second key concept is force. Force is a push or pull on an object in any direction. In the case of the train, there's the frictional force we just discussed in the negative x direction, but there's also a gravitational force acting on the train in the negative y direction, and a normal force in the positive y direction. Normal force is the force that prevents solid objects from passing through each other. In this situation, the train tracks will be exacting a normal force on the train, preventing it from passing through them. The gravitational force and normal force cancel each other out because the train is moving perpendicularly to the y-axis. The last concept is inertia, which comes from Newton's first law. Newton's first law states that an object at rest will remain at rest as long as there is no external force acting on it. Stemming from this law, inertia is the tendency of objects in motion to stay in motion and objects at rest to stay at rest, unless a force causes its speed or direction to change. Now that we reviewed these topics, we can now answer the question, how is the train able to start moving from a standstill? In order to overcome inertia, an object must generate enough force to overcome static friction before being able to move. The net force must be in the positive x direction. This means that if you were to add up the positive and negative forces in the x direction, the sum would be a positive value. In this case, the train's mechanisms must exert a force that overcomes the inertia by being greater than the frictional force between the track and the train, which hinders the train from moving. If the force in the positive x direction is greater than the frictional force in the negative x direction, the train will be in motion in the positive x direction.